What I'm going to do is to give a very rapid overview of the impacts of climate change on human health, and then say something about the actions that we need to take in order to protect health as far as we can in the face of climate change, and to capitalize on the healthcare benefits of moving towards a net zero carbon economy. It's a big topic, it's growing very rapidly. There are conferences that last for several days covering all of these issues, so I won't be able to be comprehensive, but I'll try to give you an overview. So this first infographic tries to summarize this complex and in some cases evolving situation. And at the top of the slide, you can see how greenhouse gases are contributing to climate change, causing increasing temperatures, of course, changes in precipitation, rising sea levels, and then through a range of social and other social, economic, and other environmental factors. These modulate the way in which climate change is experienced around the world and the impacts it has on our health. And through a range of different exposure pathways, these have impacts on health outcomes, a range of health outcomes. And these range on the left from the most direct and obvious ones, like the increase in heat-related deaths, particularly amongst the elderly, not exclusively, but particularly amongst the elderly. Obviously, it affects labour productivity, as we've heard. There are implications of wildfires, increasing wildfires. We're beginning to understand that wildfire smoke is damaging to human health, probably more damaging than kind of average urban air pollution, has greater oxidative potential, and increases the death rates from heart disease and respiratory conditions in the days following exposure. Also, the effects on infectious diseases, very wide-ranging, waterborne diseases, foodborne, vector-borne diseases, and as we'll hear later, also zoonotic diseases, those diseases transmitted from animals to humans. Undernutrition, of course, is a particular concern in many parts of the world as a result of declining crop yields, but also as carbon dioxide is put into the atmosphere, that stimulates the growth of some crops, but it also reduces the micronutrient levels. So there's a double whammy, a double impact, if you like, reductions in the yield of crops, but also declines in the nutritional quality of some crops, reduced micronutrients, which are a particular problem for many people living in low-income countries, reduced protein content, and so on. And then the effect on vector-borne diseases, which I'll mention in more detail in just a moment. A very wide range of vector-borne diseases. We think of those in relation to low-income countries, but they also affect Europe as well. And then on the far right, you can see the category which is most difficult to quantify, but probably the most important, and that's the effects on a range of social factors. Of course, economic growth, as we've heard, displacement of populations, probably increased conflict, again, as we've heard. So increasingly, we're trying to attribute the health effects to climate change and health, to human-induced climate change. We've already heard briefly that attribution is a really important area for scientific research. And the last review I read suggested there are about now 13 papers that attribute health effects to climate change. So they distinguish between natural climate variability and human-induced climate change. And we're increasingly able to attribute the health impacts to human-induced climate change. This is one example, led by my colleague Ana Vicero Cabrera. And what she did with a very large group of researchers was to look at the attributable heat-related deaths in recent decades that could be attributed to human-induced climate change using data from 43 countries. And you can see that there are big gaps on the map. There are big grey areas where we don't have data, like much of sub-Saharan Africa, much of Asia and so on. But where we do have data, we can state that around about a third of the total heat-related deaths over recent decades can be attributed to human-induced climate change. And this is a very active area of research. You can see that temperature, from this slide, you can see that temperature and mortality are differently distributed depending on where you are in the world. And even within Europe, you can see that there are big differences. If you look at the top part of the slide on the right there, you see Stockholm, actually not very big increases in cold temperatures or at hot temperatures, probably because of the housing and also because of the local climate. In Madrid, there's a much steeper U-shaped relationship, and also in London. We have high cold-related deaths and very rapid increases in heat-related deaths as well. And the cold-related deaths are partly related to energy poverty and poor housing. But it isn't just human death rates that go up, also affects particularly vulnerable groups. We've already heard about the problems of labour productivity, but there's one group that's particularly vulnerable, and that's pregnant women, subsistence farmers. We're doing work with our colleagues in the Gambia and West Africa looking at the heat exposure of these pregnant women subsistence farmers. They don't have a choice as to whether to work. They have to work to feed their children. And you can see the research team literally in the field with the subsistence farmers here measuring the wet bulb globe temperature, which integrates air temperature with humidity and also with solar radiation through the black globe, which you can see at the top there. On the left, you can see the relationship between the wet bulb globe temperature and the fetal heart rate. So the fetal heart rate goes up in direct proportion to the temperature exposure, the heat exposure. And we believe that has deleterious effects, negative effects on the fetus. And in some cases, these heart rates are very high indeed, into the level of kind of fetal distress. And you can see on the right the kind of physiology of all this, which I don't have time to go into detail about. But basically, the woman's hematological or hemostatic blood system is attempting to redistribute the blood in order to reduce the heat loading, and that's diverting blood from the placenta to the skin in order to increase the heat loss, and that deprives the fetus, we believe, of blood essential nutrients. We also know that many other pathways can affect human health, as I mentioned earlier. Drought is one of them, and we know that climate change increases the risk of drought. The work of Freddie Otto and her colleagues has suggested that the kind of drought we've seen in the Horn of Africa and Somalia could be 100 times more likely due to climate change, because increased temperatures increase evapotranspiration. That's the particular driver. And you can see that drought can affect health through many, many pathways. Changes in infectious disease distribution, of course, changes in air pollution, and changes, of course, in food availability, leading to undernutrition. So it can also stimulate, of course, migration. So a range of different pathways by which drought can have profound impacts on physical health, but also probably mental health as well, as I'll mention in just a moment. I mentioned wildfires around the world, increasing risks of cardiovascular, all-cause and respiratory mortality in the 3 days following exposure. And in some cases, these exposures are very, very high indeed. And you probably can't see the map, but it does show us the kind of red and orange circles where you get exposures of over 100 micrograms per cubic meter. So where we're sitting at the moment, I don't know the exact exposure, but it's probably somewhere between 10 and 20, something like that. So very, very high exposures indeed for these short periods. And although long-term exposure is more important for health, these short-term exposures to particulates can also, as I've shown, have an impact on health. Vector-borne diseases, there's a lot to say there. I'll just mention a few facts. One is that the ability of these vector mosquitoes, Aedes aegypti and Aedes albopictus, to transmit diseases like dengue has increased over recent decades, as shown in this paper from my colleagues at the school, Chris Murray and others. And you can see how their vectorial capacity, the ability to transmit dengue, has increased over recent decades. That's not just a problem for the tropics and subtropics. We're also seeing Aedes albopictus in Europe. We've seen transmission in France, for example, in Madeira, and it seems to be spreading, the vector seems to be spreading north and west with climate change. It's not the only factor, but it's an important factor. Also, and I think we'll hear more about this later, but these zoonotic diseases, emerging zoonotic diseases, may also increase, probably as a combination of decreasing biodiversity, changes in land use and climate that forces together animal species in smaller areas of land, supporting and increasing the transmission of viruses between different animal species and between animals and humans, particularly where we're seeing urbanization, rapid growth in urban populations overlapping with this increase in transmission, as you can see in the purple areas of the map here, where the transmission is likely to be greatest, including parts of Africa, parts of Europe, North America, South Asia, of course, and parts of Latin America. Also, there's a link between ocean health and human health, which we're beginning to understand more about. This is just one example from Europe, which shows you how the coastal waters, with environmental conditions that are suitable for the transmission of Vibrio species. Vibrio, obviously Vibrio cholera is a big killer around the world. These are not cholera Vibrio, but they can cause adverse health effects. And you can see, I think, from the colour on the map, that in the Baltic and in the Black Sea, you can get increasing transmission of these Vibrio species if you bathe in this water. And in some cases, that can cause quite serious health outcomes, particularly for people who are immunosuppressed. So we are seeing this relationship, this growing awareness of the relationship between ocean and human health. And in Bangladesh, there's increasing saltwater intrusion. So probably it's not just due to sea level rise in Bangladesh, it's also due to the local environmental challenges of damming of rivers for energy and for shrimp farms and other things. And we're noticing that this is papers by our colleagues, led by our colleagues based in Bangladesh, showing relationships between drinking water sodium and blood pressure in both pregnant and non-pregnant people. And we're seeing in pregnant women an increased risk of preeclampsia, which of course conveys an increased risk of adverse pregnancy outcomes. So this is the kind of thing we would expect to increase more as sea levels rise. I've mentioned the effects of climate change on food, and we've heard it from other speakers as well. We tend to think of that as a problem for low-income countries, but it could be a problem for Europe as well. And one reason why that's so is also shown in this slide, which shows you the increasing dependence of the food supply in the UK. This is particularly fruit and vegetables on climate-vulnerable countries. So if we increase our imports from these countries as they start to bear the brunt, the impacts of climate change, then our food supplies may be increasingly affected. Now, fruit and vegetables are very important for human health because you need an adequate intake of fruit and vegetables to reduce your risk of cardiovascular diseases and other non-communicable diseases. So you need about 400 grams a day for optimum effect. It's not just physical effects, it's also mental health effects as well of climate change. And we're realizing that climate change can have a range of mental health effects because of exposures to floods, droughts, wildfires. When you follow these populations up for a year or so, you find quite long-term effects, increasing anxiety and depression, post-traumatic stress disorder, and so on. And also shown on this slide, on the right side, you can see the results of recent surveys of climate anxiety amongst children and young people. This is a study in, I think, 15 countries, showing pretty high levels of climate anxiety, and the grey bars show you the impact on functioning. So overall, about 45% of these young people said that the effects on their mental health was so much that it interfered with their functioning as people. They had these pervasive worries and anxieties about the climate. So it's having an effect on mental health now, particularly amongst the young. So we need to act promptly, quickly, as we've already heard, and we need to both adapt to the climate change that we can't prevent, to reduce the effects on health, well-being and the economy, but also to mitigate, to cut emissions. And we need to do both simultaneously. We tend to think of adaptation and mitigation as separate activities, but we actually need to integrate, as we've already heard, adaptation and mitigation to avoid maladaptation. One example might be air conditioning. Of course, you can put air conditioning everywhere, but if you do that, you increase your burning of fossil fuels in many countries, increase air pollution because of that increased burning of fossil fuels. You also have to put the heat somewhere, so you pump it outdoors. So when you go out of the buildings, you're actually exposed to greater heat, the greater urban heat island. And of course, it increases inequalities as well because the poor cannot afford air conditioning. So we need to develop better early warning systems for climate events, but also to cut emissions. And in cutting emissions, we can really benefit human health, and I'll mention that in just a moment. But let me just say a word about adaptation. There are growing literature on how we can adapt to climate change to prevent adverse health effects through better early warning systems on heat, on vector-borne diseases. This is just one slide showing work by our colleagues Felipe Colón González and others, using model climate forecast using a super ensemble of probabilistic models to predict dengue risk, and this is in Vietnam, but they've been working in a whole range of different countries. And they've shown that using these seasonal climate forecasts, you can predict the risk of dengue, and then you can put in place public health interventions to reduce the risk. So it's just one example of adaptation. But there's also big opportunities for mitigation. So these are co-benefits, so-called health co-benefits of mitigation. They're ancillary benefits of mitigation. They're near-term benefits, and then in addition to the benefits of reducing the risks of dangerous climate change. And the reason for that, there are three big pathways: reductions of fossil fuel-related air pollution, improvements of physical inactivity through improved transport systems, which give people the opportunity to be physically active, reduce air pollution exposure, and diet, of course. And I think Charles will be talking about diet, so I won't say much about that. But the Eat Lancet Commission has suggested that we could reduce premature deaths perhaps by over 10 million per year by shifting to healthier diets. Now, you may say, well, these are rather exaggerated projections. They depend on dramatic dietary change, but they give you an indication of the kind of magnitude of effect. So millions of deaths from air pollution from fossil fuels, a recent estimate. We just updated that, led by our colleagues at the Max Planck Institute for Chemistry in Mainz in Germany. We suggested over 5 million deaths a year per year. Many of these in India and China, but also in high-income countries too, hundreds of thousands overall. Physical inactivity, about 4 million, and as I've said, over 10 from diet. So big potential benefits if we could realize those benefits. And we've just published the output of our Pathfinder Commission, which I have the honor to co-chair with Helen Clark and Joy Fumafi, who you may be aware of. And this is an initiative which is really trying to synthesize all the evidence that we have about the health co-benefits of climate action. And what we found is that about 90% of the research is from modeling studies, which are modeling studies very important, of course, but they don't tell you what happens when you try to implement change. And only a small proportion of the studies are implemented actions, where they measure greenhouse gases and measure health exposures or outcomes. And this is the evidence bank that we've created, which is open access. Anyone can access it and look at the evidence that we've found. And we basically confirm that there are big potential health benefits, but the challenge now is to implement these benefits. Also, a couple of years back, the Royal Society and the Academy of Medical Sciences in the UK supported this report, which looked at how we could achieve the health co-benefits, but also avoid some of the trade-offs from net zero policies in the UK. There are a few trade-offs. For example, as I mentioned, air conditioning might be one. Another might be if we seal up buildings, if we insulate buildings very tightly, that improves the energy efficiency, but it can also increase the household air pollution exposure. So you have to be aware of these trade-offs in order to capitalize on the co-benefits. And this report summarizes the situation for the UK. There was also an accompanying air pollution report from the Royal Society, and this looked at the air pollution benefits from different net zero policies. On the right, the green arrow shows you better air quality, and on the left shows you poorer air quality. And you can see that most of these policies result in improved air quality. Some of them could have negative effects depending on how they're implemented. Biocrops, for example, burning of biofuels could increase air pollution. Carbon capture and storage depends on the technology you use and on the assumptions that you make. But overall, many of these policies are win-win. So there's reduced air pollution, better air quality, and reduced greenhouse gas emissions. But of course, the key, as we've already heard, is to implement these policies, and we're often not doing that at the necessary speed and scale, particularly in the food system, household energy, buildings, and so on, is particularly as we've heard from Baroness Brown already. We tend to think, of course, of air pollution mainly from fine particulates, and that's correct. It's mainly fine particulates that cause the damage. But also, ozone is another important air pollution. And although methane is a powerful greenhouse gas, it doesn't cause damage to human health directly, but it is an ozone precursor. And tropospheric ozone causes hundreds of thousands of deaths per year around the world. Some estimates suggest perhaps over 1 million premature deaths. And methane's responsible for about half of these deaths. So by reducing methane from changes in agriculture, food system, gas leaks, fossil fuels, and so on, we can improve human health and also improve crop yield as well, because tropospheric ozone is damaging to crops. So we've just done a study a year or so back, published, looking at the health benefits of net zero policies according to the Committee on Climate Change projections in England and Wales. And we've shown that you could get something like an extra 2 million years of life over coming decades by following the Committee on Climate Change balanced pathways scenario, and even more if you go to the widespread engagement scenario, about an extra 25%, something like that. And these benefits, as you'd expect, are from reduced air pollution, including in the household, improved diets, increased physical activity from more walking and cycling, and the use of public transport. So there are substantial benefits in a country like the UK. And then finally, in conclusion, my last slide, I don't want to completely omit the healthcare system itself. We are now beginning to understand that the healthcare system is responsible for about 4 to 5% of greenhouse gas emissions on a global scale. In the US, it's more than that. It's about over 8%, because they have a very energy-intensive healthcare system with strong dependence on tertiary care and so on. About 60% of these emissions come from the Scope 3 emissions, which are shown on the right side of the slide here. These are the emissions which are embedded in pharmaceuticals, in medical equipment and so on, which are very energy intensive to produce. So it's not just a question of decarbonising the energy supply, it's also a question of working with the pharmaceutical industry, the medical equipment industry, but also embarking and emphasising the importance of prevention. So I've mentioned the benefits of moving towards a net zero economy, and that could, at least in theory, help to reduce the burden on the healthcare system. So we're now seeing a lot of activity by WHO and others to bring together a coalition of nations to move towards more climate resilient health systems, but also in a number of cases moving towards net zero health systems, including in the UK. So I'll stop there, but just want to emphasize the fact that climate change does have wide-ranging effects, dangerous and negative effects on human health, but there are big benefits to adapting to and to mitigating climate change. Thank you very much.